Have you heard of superphosphoric acid? Well, today we're diving deep into what it is, how it's made, why it's important, and the amazing benefits it brings to agriculture. So let's get right into it. First off, what exactly is superphosphoric acid? It's a highly concentrated viscous liquid containing a mixture of polyphosphoric acids. Now you might be wondering what makes it so special. Well, the secret lies in its production process. Regular phosphoric acid, also known as H3PO4, can be thermally concentrated, meaning that water is removed through heating, which leads to the formation of longer chains of H3PO4 molecules. This process boosts the concentration of phosphorus pentoxide, P2O5 in the acid, from about 52-54% in conventional phosphoric acid to a whopping 68-76% in superphosphoric acid. This increased concentration is game-changing because it makes it a more cost-effective raw material for producing high-grade fertilizers. Not only that, but superphosphoric acid is also a valuable intermediate in the production of other chemicals like flame retardants and insecticides. So how is superphosphoric acid made? Well, it all starts with phosphoric acid, which can be produced through different methods, including the wet process, the most common industrial route, and the thermal process. However, regardless of the method used, the ultimate goal of these processes is to produce high-quality phosphoric acid, which serves as the foundation for making superphosphoric acid. In the wet process, phosphate rock is treated with sulfuric acid to produce phosphoric acid. This process involves several steps like leaching, purification, and crystallization. On the other hand, the thermal process directly converts phosphate rock into phosphoric acid at elevated temperatures without using sulfuric acid. This method typically uses a molten salt medium to facilitate the reaction and the subsequent separation of phosphoric acid. Once high-quality phosphoric acid is obtained, it undergoes vacuum evaporation to remove water and increase the concentration of phosphorus pentoxide. This process takes place in multiple stages to control the viscosity and prevent overheating. By carefully controlling the temperature and duration of these processes, manufacturers can produce superphosphoric acid with the desired characteristics. Now let's explore the fascinating reactions that take place when using superphosphoric acid to obtain high-grade fertilizers. Superphosphoric acid's primary use in the fertilizer industry is its reaction with ammonia to produce ammonium polyphosphates, commonly known as APPs. Unlike the reaction between conventional phosphoric acid and ammonia, which primarily yields monoammonium phosphate, MAP, and diammonium phosphate, DAP, the reaction with superphosphoric acid is more complex and produces a mixture of polyphosphates. These polyphosphates have unique properties that make them valuable in agriculture. When superphosphoric acid reacts with ammonia, it forms a series of compounds with varying nitrogen to phosphorus ratios. The resulting mixture typically consists of monoammonium phosphate, which can be represented as NH4H2PO4, or more complex structures with multiple phosphate groups linked together. These complex molecules contain both ionic and covalent bonds, giving them distinct characteristics compared to other nitrogen and phosphorus containing fertilizers. The reaction between superphosphoric acid and ammonia is highly exothermic, releasing a significant amount of heat. This reaction must be carefully controlled and managed in a reactor to ensure a stable end product. The careful balance of reactants, temperature, and pressure in the reactor determines the final composition and quality of the ammonium polyphosphates produced. The entire process is meticulously monitored and regulated to optimize the yield and ensure a consistent fertilizer product. After the reaction is complete, the resulting mixture is purified and concentrated to remove any unreacted materials or byproducts. The final product, often sold under the grade 10340 or 11370 liquid fertilizer, is a prime example of a high-grade fertilizer derived from this process. The numbers represent the percentage of nitrogen, phosphorus, and potassium respectively. This liquid fertilizer is highly concentrated and contains a blend of polyphosphates that offer several advantages over other phosphorus sources. One of the main benefits of using superphosphoric acid to make high-grade fertilizers is the increased nutrient concentration. Since superphosphoric acid has a high P2O5 content, the resulting liquid fertilizers also boast high concentrations of phosphorus. This means that a smaller volume of fertilizer is needed to provide the crops with the required amount of phosphorus compared to fertilizers made from conventional phosphoric acid. Consequently, using superphosphoric acid reduces transportation costs associated with fertilizer application. Furthermore, the polyphosphates present in the fertilizer act as chelating agents, enhancing the availability and uptake of essential micronutrients such as zinc, iron, and manganese by plant roots. By forming stable complexes with these micronutrients, polyphosphates prevent them from reacting with other substances in the soil that could render them unavailable to plants. This chelating effect ensures that plants can access these vital nutrients, promoting healthy growth and development even in soils where these micronutrients might otherwise be in limited supply. Another advantage of superphosphoric acid-based fertilizers is their versatility and ease of use. Liquid fertilizers like those produced from superphosphoric acid are highly versatile and can be applied using various methods, including drip irrigation systems, foliar sprays, and fertigation, which is a combination of fertilizer and irrigation. This flexibility allows farmers to tailor the application method to specific crop requirements and soil conditions. Moreover, liquid fertilizers offer precise application, enabling farmers to control the amount of fertilizer applied, reducing nutrient waste and minimizing environmental runoff. Additionally, superphosphoric acid-based liquid fertilizers are compatible with a wide range of nitrogen and potassium sources. They can be easily blended to create custom NPK formulations, which are essential for meeting the diverse needs of different crops and soil types. This customizability allows fertilizer manufacturers and farmers to develop tailored solutions for specific agricultural requirements. To sum up, superphosphoric acid is a remarkable substance with a multitude of applications in agriculture and beyond. Its high concentration and unique properties make it an ideal solution for producing high-grade liquid fertilizers that offer several advantages over traditional solid fertilizers. By utilizing superphosphoric acid, farmers can enhance nutrient uptake, improve crop yields, and contribute to sustainable agricultural practices. Thank you for joining us on this journey of discovery as we explored the world of superphosphoric acid. If you found this information valuable, don't forget to hit the like button below and share it with your friends. We would love to hear your thoughts and any questions you may have. Please feel free to drop them in the comment section below. Your engagement keeps us motivated to continue creating informative content for you. Before we part ways, we invite you to subscribe for more exciting content on science and technology. Stay curious, keep asking questions, and never stop exploring the wonders of science. Until next time, stay awesome and keep learning. Thanks for tuning in.